on to the Pythagorean theorem. This is the last 8th grade standard we're going to cover before we jump into the high school curriculum. Before we jump into this, I'm going to post along with this video an additional video on how to find the square root of a value. That's a skill you're going to have in place before you can solve for a hypotenuse or a leg, missing leg or hypotenuse of a right triangle. This should have been covered in previous courses, but if you're not sure how to do that, please check out that video. You will also need a calculator for this lesson. So if you do not have one, it'd be a good idea to find one, or you can discover some online tools such as desmos.com. It's a good graphing calculator that you can use as well. All right, so we need to go over vocabulary for this unit. It's important. We're going to introduce some new terms. So we're going to start with this idea of a hypotenuse. A hypotenuse is a side opposite of the right angle in a right triangle. So if we're looking at a right triangle, the hypotenuse is always going to be away from the right angle. So if I'm going to draw an arrow here, I like to always include this kind of arrow, this idea that it's going to be not connected to the hypotenuse, because you'll see the leg A and B are touching that right angle, so the hypotenuse is going to be away from it. The legs are the two sides that form a right angle and a right triangle, so basically they're the two sides of a right triangle that connect to make the right angle. So in this case, they're on the left and the bottom side of the triangle. Finally, a theorem is just a relationship in mathematics that has been proved. So as you're going through this video, please feel free to pause whenever you need to write down your notes and then keep going when you're done writing down. I'm just going to keep going now. All right, the Pythagorean theorem. So in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So basically that means if we take A and square it, and then add it to B after we square it, that will be equal to whatever C squared is. Right? At this point, we can use basic math to determine any of the missing sides. All right, so once again, if you have to pause, write that down, do so. I'm going to go ahead and jump into examples. Okay, so find the length of the hypotenuse in a right triangle with leg lengths of 9 and 12. So first thing you want to do is to sketch a triangle. So I'm going to go ahead and do that now. Doesn't matter. Doesn't have to be pretty, just kind of sketch it so you can set it up correctly. So I'm going to say this is my right angle. Does not have to be to scale. So I know my leg lengths are 9 and 12. I'm going to put my 9 here and the 12 there. Like I said, it does not have to be to scale. It's perfectly fine. You could switch it. It doesn't really matter. And then my hypotenuse is always going to be opposite of the right angle. So I'm going to go ahead and put my hypotenuse here. You'll notice that the hypotenuse up above, when we looked at that, was represented by the letter C. Also in the Pythagorean theorem, the hypotenuse is represented by the letter C. So I'm just going to put C in here. All right, now to set this up, 9 squared plus 12 squared equals C squared. So you notice the hypotenuse is opposite of the two legs. We know that 9 times 9 is 81. We know that 12 times 12 is 144. And we know that 81 plus 144 is 225. Sorry, I don't want to write it that way. Bad, Mr. Robinson. I'm going to get rid of that. I actually want to simplify the left side. So be C squared. This is 225 equals C squared. So far, so good. Now you're probably wondering, Mr. Robinson, what do I do with this squared thing? So as I previously said, I'm going to post an additional video which will remind you how to find the square root of something. The square root is the radical sign on your calculator. So what you want to do, the radical sign is basically this check mark with an overhang. That will undo this. So whatever number is multiplied by itself to equal 225, the square root will undo that value. So in this case, the square root of 225. So in your calculator, you want to enter the radical sign and then number 225 and hit enter. And you'll find that C equals 15, or 15 equals C. So that is the length of this side. So I could say the hypotenuse is 15 units. Okay, so remember, when you're taking the square root of a value, it's undoing the square. So on your calculator, it will look something like this right here. I cannot tell you how each individual calculator works without seeing the calculator, knowing the model. Some calculators you're going to have to hit a second function before you use it. Some you will not. Some will have you enter the number and then hit that. It just really depends on your calculator. So if you have an issue with that, contact me in class and I'll help you sort it out. You could also just put in YouTube the model of your calculator, and I'm going to guess there's probably more than one video showing you how to use it. All right, the next one, we already have our triangle set up here. And you notice that we have the leg and then we have the hypotenuse. So we have the hypotenuse, which means we're going to find one of the leg lengths. Okay, so I'm going to label my leg over here either A or B. It really does not matter as long as it's A or B and not C. Now, this is the kind of problem that most students will make mistakes on. If you're trying to find the hypotenuse, most students, when they have this kind of basic technique down, they always set it up correctly here. Now, I want you to pay close attention to how I set this one up differently than the previous problem. This time, I'm going to write down A squared plus 12 squared equals 14 squared. You'll notice that the variable I'm trying to solve for is actually on the left side this time. We know the hypotenuse. So we know the hypotenuse is opposite of the right angle, so we know we're solving for a leg. So I can't do anything with A squared yet. I'm just going to rewrite it. I know that 12 times 12, or 12 squared, is 144. And I know that 14 times 14 is 196. So there's that. Okay, now you're going to treat this like any other equation up until the last step. What you normally do, you have the variable here, you have a constant there, you're going to go ahead and subtract 144th on both sides. Okay, there's that. The 144 cancels out. I'm left with A squared equals 196 minus 144 is 52. Now, I know that the square root of 49 is 7, because I know 7 times 7 is 49. So I know this is going to be a little bit bigger than 7, but I'm going to go ahead and put the value into my calculator so I have an exact answer. So my calculator gives me this as an answer, 7.27. I'd usually say the number correctly, but I'm going to keep on listing off digits. 0, 2, 5, 5, 1. Please don't give me that as your answer. It says round to the nearest tenth. Right? So we're going to look at the 100 spot. The 100 spot is a 1, so we're going to leave that 2, 2. So we could say A is approximately 7 2/10. And then since we don't have a measure here, I'll just go ahead and add units into my answer. So if we have like centimeters, inches, feet, or some other kind of measure, we'd put that there. But since we don't, we're just going to go ahead and type in units. All right, we're going to go over some more examples in class. And I will expect you to have these notes done before we start, especially the procedure at the top. We'll be working on this probably up to right around Thanksgiving break. All right, hope you guys have a good one. See you in class.